Hello, everyone. My name is Sam Chinellato, and I'm a platform engineer at IBM. Over the last year or so, my team has delivered hundreds of AI pilots across Asia Pacific and across a variety of different industries. What I want to share with you today is some of the lessons that we learned while doing so, as well as some of the tooling and particularly how we use GraphQL to be able to deliver these pilots at scale and at speed. We're also going to be building our own small AI application to show some of the benefits of using such tooling. So let's get started. For those of you maybe less familiar with developing an AI application, this is a very quick overview of what a simple retrieval augmented generation application might do. So as you can see here, we have often a question that's coming in from our user, and that's submitted through a chat interface. You could think of a chatbot, for example. A RAG application then needs to be able to embed this question. That's often done using an embedding model. And it's then going to query an embedding store. So this might be called, for example, a vector database. And this is where we store kind of our knowledge data. We're then retrieving relevant segments of that question, so segments that match the query from our user. And once we've done that, we feed the question from our user, the segments that have been fetched from our embedding model, as well as a prompt for our GenAI model to our large language model. So this is something more commonly, you might have heard of ChatGPT, for example. That's a common example of one. We then wait for our large language model to generate an answer, and then we return that answer back to our user. So at a very, very high level, this is what a RAG application and developing a RAG application might look like. But what makes RAG applications successful? Well, in our experience, these are two kind of key success criteria for the success of an AI application. Firstly, a successful AI application requires effective collaboration between your AI engineering team and your development team. Often, the RAG pipeline that is part of your AI application is a dependency for your developers. And if you have an AI engineering team that is serving multiple RAG pipelines across multiple teams and applications, you don't want them to become a bottleneck. At the same time, reducing friction between these two teams leads to quicker experimentation. And really, in our experience, the success of a RAG application is all about rapid experimentation. RAG applications and AI applications are successful when they're specifically tuned and tailored to the business problem they're trying to solve. And the best way to do this is to rapidly prototype and be able to continuously test that your application is solving the business problem or the problem that it's designed to solve. Now, of course, all applications start small. And as your application is relatively simple and maybe as a pilot, ensuring no friction between your AI team and your development team, as well as rapid experimentation, is not too much of a problem. So for example, you might be having to manage your embedding model, as we discussed earlier, or kind of having to manage your large language model as your dependencies. You might have a vector database, and with a relatively small team, you might be able to rapidly prototype your RAG pilot. Of course, things change drastically when you are dealing with an enterprise environment. as enterprise, I guess applications and AI applications enter enterprise environments, the complexity grows exponentially. So suddenly, as you start trying to develop or maybe release a new version of your application, you're having to contend with a great deal of dependencies, and having to manage a real complex environment. So this might range all the way from having to prompt engineer your large language model to make sure it doesn't hallucinate, to might, for example, entail checking your data pipelines to make sure that the data that's feeding your vector database and your knowledge kind of store is not going stale. It might include making sure that you have appropriate guardrails, and you're governing your large language model to make sure that it is not giving answers that are out of what you're expecting. For example, sharing personal information or PII data, as well as the kind of usual, or I guess, longer-lived challenges of software development, such as application hosting and making sure that your application is available, and that you can, ensure that it can handle load, for example. So, while you might be able to manage this at first and ensuring that you're able to quickly experiment with RAG initially, you start requiring tooling, and you start requiring picking the right tool as your application scales towards enterprise. So what do you require from this tooling in order for your application and your RAG application to remain successful? Well, firstly, whatever tooling you use needs to be flexible. And this is particularly because as you develop a new version of your application, as you start testing with it, you need a tool that is flexible to allow you not to introduce too many breaking changes as you are experimenting. If the cost to refactor is really high, it's going to be difficult for you to keep developing your RAG application. Secondly, you require efficiency. Particularly in complex environments, and I guess enterprise environments, you want to make sure that you're minimizing, for example, the amount of requests between all these services, and you're not duplicating requests, and you're really maximizing that efficiency. Thirdly, performance. As always, in large, distributed systems and enterprise environments, performance is key. Often, for example, our chatbot that we sort of quickly glanced at earlier has a latency requirement. If you submit a question to the chatbot and it takes minutes to respond, it's not going to be particularly useful. And again, as the complexity of your environment grows, as you introduce databases, as you introduce other dependencies, you want to make sure that the solutions that you choose are performant. And finally, automation. So as the complexity of your environment that you're deploying is, as you make your way towards the enterprise environment, automation becomes really key. You can't have all of the dependencies required for your application managed by humans. You need an abstraction layer to help you easily manage your application dependencies. So luckily, some of these problems have already been solved. GraphQL, in its essence, was developed by Meta to allow and encourage for rapid experimentation. And for that reason, it is very good at addressing the first two requirements that we outlined in the previous slide. Flexibility is sort of built from the ground up in GraphQL. By having a schema, you have a looser contract between your client application and your server application, which means that as you experiment with, say, your front end and you're building your chat interface, you're less likely to make breaking changes to your RAG pipeline or your RAG server. Similarly, GraphQL is designed to be efficient from the ground up. One of the, I guess, core benefits of using GraphQL as your API interface is that it will minimize and reduce the number of requests between your client and your server. So what would have previously taken several REST requests can be minimized to just one REST request using GraphQL. But of course, GraphQL does not solve all of the, does not meet all of the requirements we outlined in the previous slide. And this is where AI flow orchestration comes in. In order to keep managing your AI application effectively, you need a tool that has performant infrastructure and makes performant choices out of the box. And not only this, but abstracts this performant tooling in an automation layer to really allow you to manage a complex environment that a RAG flow requires in an easy and intuitive language, and really reducing the complexity burden on your development team. If you meet all of these requirements, you will be able to iterate a lot faster, and you'll be able to ensure that your AI application remains useful. But that's probably enough talking. Let's start looking at how this might look like, might play out in practice. And we're going to have here a quick demo of developing a simple RAG application. And we're going to see how we can manage what is a pretty complex environment that is a RAG pipeline through a simple GraphQL endpoint. So what you're going to be seeing here is a question being submitted through our chat interface. We're then going to be hitting a single GraphQL endpoint, and that GraphQL endpoint is going to govern an AI orchestration flow that is going to handle our RAG process. We're going to be calling our embedding model, we're going to be calling our vector store, and we're going to call our large language model through an automation layer that is very easy to manage. And then once our large language model has generated an answer, we're going to display it back to our user. So let's jump in. So here you can see my simple RAG application, my chatbot, and this is sort of pre-configured to talk to our large language model in the backend. So what I can start doing is ask it a couple of simple questions, such as, what is GraphQL? And it's going to generate an answer for me, no problems. And this is because the model was trained on huge amounts of data, and somewhere in its training set, it learned something about GraphQL. And so it's able to answer my question. Likewise, if I ask it another question, such as, why should I use GraphQL? It's going to go ahead and tell me why I should use GraphQL. Now, of course, where we start hitting challenges is when we want to ask specific questions to our large language model on data that it likely hasn't seen. For example, a question such as, who is presenting on GraphQL at Apidays 2024 might stump our large language model. Because of course it hasn't seen the schedule for APIs 2024. It's probably been trained a long time before seeing the schedule, and so this is answering this question is a good use case for a RAG flow. So let's have a look at what's going on behind the scenes of my application. As you can see here, the whole application makes a single call through a GraphQL interface to our AI layer. So in about 30 lines, I'm able to effectively process the entire query. And just think about how many requests I would need to make if I was using REST to do this. What I'm using to manage my AI layer is a tool called watsonx Flows. And it makes it really easy for me to start experimenting with RAG. So what I've done here is scraped a couple of pages from the Apidays website. I've done a little bit of data cleaning just to kind of make sure that it looks nice and it's legible, but I've basically taken the schedule from Apidays 2024 and I've stored it in a markdown file. And what I can start doing with watsonx Flows is start processing my data in a format that is suitable for our embedding model and our embedding store. So watsonx Flows, through again a simple CLI interface and a CLI command, is going to be generating a GraphQL docs like TSV. So this is effectively my data processed to a state that is suitable to be ingested in my embedding store. So this would be my vector database. And then all I need to do is deploy this data. And the watsonx Flows CLI is going to take that data and it's going to upload it to my endpoint. And it's going to manage that endpoint for me through this GraphQL interface. So as you can see, we're generating our GraphQL endpoint. And of course, having abstraction doesn't mean that you should sacrifice flexibility. And watsonx Flows is particularly good at this, and this is where it really shines. So while I have this layer of abstraction around my AI layer, I'm still able to have some flexibility around how I want to orchestrate this layer. So what I was doing in previously or in the first part of the demo is calling this my questions flow. And a flow is effectively a series or a collection of steps that allow you to kind of flexibly orchestrate your, I guess, the AI layer of your application. So here I was calling a prompt that I just had stored in this config file, and then I was asking the large language model to generate a response to that question. But of course, now our use case has changed, and I want to do RAG. So how would I do that? Well, this is where the my RAG flow comes in. So as you can see here, my RAG flow is going to take the input from my application. It's then going to find the documents. So these documents, markdown documents we've stored in our database. It's going to find the documents that match my user query the best. We're then going to build our prompt from these documents and the question. We're going to ask our large language model to generate a response to my question. And finally, we're going to add some information or some sort of metadata about that response. And we're going to return that back to my front end. What's really cool, again, if we need to start, or if new requirements come up and we need to, for example, implement guardrails around our large language model, we could do so again using a different flow, such as my RAG with guardrails, which will take effectively the answer generated from the large language model and actually try and return a hallucination score, or how likely that model was to hallucinate. And then we could handle that differently in our front end, for example. We might decide not to show the answer to the user if we are pretty confident that it's hallucinated. So In a few minutes, I've deployed my documents to my vector database. What's Flows has managed that endpoint for me. And all I need to do as a developer now is change my flow name, right? So I no longer want to call my question, I want to call my RAG. So what I should be able to do now is ask again. And instead of calling my question, and now I guess through RAG, my large language model, my application is able to answer the questions that are sort of more specific to Apidays 2024. I can ask it again, can you recommend talk on day 2? I'm going to go ahead and query that markdown that we've stored in there, and it's going to use that to be able to answer these questions. So just a quick little aside on what Flows Engines and what it is and what it does. It's a tool to really allow developers to easily build enterprise-grade applications with generative AI. It provides a really intuitive CLI to help you build, run, and manage your application. It's exposed entirely through a GraphQL a declarative API endpoint, and it provides a really performant AI abstraction layer around the complexities of, for example, RAG. It does so without compromising the flexibility of, I guess, specific solutions by exposing this through an intuitive and declarative language and automation flow. So to wrap things up, I wanted to leave you with kind of 3 key messages from this presentation. For your AI application to scale, you require platform automation. Specifically, as you enter more complex environments, you require an automation layer to manage the complexity of your AI infrastructure if you want to keep experimenting rapidly. You need to keep experimenting rapidly for your AI solution to remain valuable. You require the flexibility of being able to use, for example, a tool like GraphQL and not making breaking changes if you want to make sure that your AI solution remains useful. And finally, if you want to accelerate the time to value of your AI application, reducing friction between your AI and development teams, we are in fact now all AI engineers, is going to be critical. If you allow your AI team to become a bottleneck to your development, you're going to move slower. Thank you very much for listening.